Welcome to my channel, and today we are gonna go talk about sort an array. There are multiple ways to perform sorting. Sorting is one of the most basic techniques that everyone should know about, especially if you're getting started with software engineering interviews, and if you're just a general computer science student. This is like the first thing that you end up studying about, and it's very important to be very thorough with it. There are multiple ways to going about doing this problem in O of n log n time. In this video, we are gonna just start talking about merge sort. Merge sort is totally fair game. I've actually been asked this question on a phone screen by a Tinder hiring manager. I actually remembered struggling with it because I didn't understand divide and conquer, which is what merge sort is all about. One, we divide, we split into smaller inputs, and two, we conquer. We need to solve the subproblems. This is what the recursion tree is going to look like. We are going to divide the input into smaller subarrays, and we divide them until we cannot do so anymore, until these subarrays are of size 1. Once we reach that, we can now easily conquer them by merging them in ascending order. And by doing so, we'll eventually end up with our answer. And this is the pseudocode for that. I'm sure your professors or ChatGPT even can spit this out for you. And if we go through the step-by-step, this should be fairly familiar to you guys on how this works. I have not written out the merge function yet. This is because this is fairly straightforward. I expect you guys to know this already. I ask my candidates merge sort sometimes, and a lot of times they are able to come up with this solution fairly quickly. And a strong follow-up that I have is, how about merge sort without recursion? And this becomes a little bit tricky. And I really like this question because it truly tests whether or not you understand divide and conquer and just merge sort in general. Very few candidates can do this, but with enough conversation and hinting, I feel many candidates can actually get to the solution. So how does this actually work? This is not too different from its recursive counterpart. We're still going to do divide and conquer. And how we're going to do this is we're going to start bottom up first. And we do that by starting with a subarray of size 2. We're going to split this input into multiple subarrays of size 2. And we have a step from mid, which we are going to use to further split these subarrays of size 2 into its left and right parts. And we're going to take these individual parts and notice that they are subarrays of size 1, and we are going to conquer them. We're going to solve the subproblem by merging these pairs. And notice that 1 and 5 have been swapped. 1 and 2 have not been swapped. They're in their perfect order. 0 and 0 also are in their perfect order. In our next iteration, notice we are going to multiply our two values by 2. So step from mid changes to 2, and our subarray becomes of size 4. So what this means is when we put our step from mid here, we know that everything to the left of this has already been sorted by the previous step, and everything to the right of this subarray has been sorted by the previous step. So in this step, we're going to take the left and right side, and we are going to conquer them. We're merging them, and notice we have 1, 1, 2, 5. Also notice we're not messing with the last two elements because they're of size 2. And they are not of size 4. In our final iteration, we're going to multiply everything by 2 again. Notice our step from mid is now 4. Our subarray is supposed to be of size 8, but we're going to use 6 instead because 8 is too big. 6 is the maximum size of this input array. And with this, we are going to take our final left and right subarrays, and we are going to merge them to get our answer. So this is it, you guys. This is basically merge sort without recursion. This is the Python code I actually have to the left here. It's describing everything that we just discussed. And if we go through the step-by-step, you can see the logic that unfolds where we are performing these bottom-up approaches to solving these subproblems and we are finally arriving into our answer over here. And this actually is the same time complexity as its recursive counterpart. The inner while loop takes O of n time because we're going through each and every element, especially in our merge, and the outer while loop runs in log of n time as we are multiplying our step for mid by 2. So that gives us log of n times n, which is n log n. I am going to run this code exactly word for word in Leetcode. Check this out. We have our code. Everything you see here was copied and pasted from the code that you saw earlier. And I've also gone and written the merge function, which I told you that you should know about. And note that this actually has a space complexity of O of n, but we save a bit on the space that we incur upon a recursion. I have not submitted this code. I have not done this yet. So I'm going to go ahead and submit this, and we have an answer.